Kirk, you
Yep,
here? Great.
I'm here.
Okay. So let me go ahead and introduce you. Kirk is our speaker, the other speaker tonight. He is going to be talking about Crystal. He's been
Hmm.
writing software for a long time. You could probably ask him about Perl. It looks like he wrote Perl in the early 2000s. But he's got a strong Ruby bias. I'll be interested to hear when he actually discovered Ruby and what, if he has such a strong Ruby bias, why he's not talking about Ruby. But he is currently a principal developer relations engineer at New Relic. So Kirk, please go ahead and take it away.
Sure. All right. And so I'm going to be trying something a little bit new here. So let me know if this works. If you have your screen in the gallery view, just change it to the speaker view, and you should be able to see me and a view of my browser right now. Which has the slide deck on it. So if it looks good, we're just going to go with it just like this, because this will make it a little bit easier if I decide to actually show you some code or something like that. So yeah, I'm talking about Crystal tonight. Crystal, well, I'll get into what Crystal is in just a minute, but for myself, I'm as Dan said, a principal developer relations engineer at New Relic. I've been there now for almost 3 months actually, but we've only been public with it for 2 weeks. So some aspects of that whole thing are still pretty new to me, but it's been a lot of fun so far.
I'm sorry, Kirk. I should have asked you this. It's okay to record this?
Absolutely fine to record it, yes.
Cool. It's recording.
And yeah, just a little bit sort of an overview of me. I've been doing Ruby since 2001 and doing Ruby web apps actually since 2002. I did a stint of about 2.5, 3 years, something like that, where I was the Ruby 186 maintainer. And I just love technical bits, fiddly bits, internals, getting down into the C and things like that. That's kind of the stuff that I like doing. So to dive right into this. So Crystal is a compiled language. It's statically typed. It's built on top of LLVM. And it was, I think the first version of it was written 2013 maybe, and that version used Ruby as its compiler. And so you wrote your code in Crystal, Ruby compiled it down to an LLVM representation, and then LLVM took it from there and turned it into an executable binary. And after a couple of years, they got to the point where Crystal could be written in Crystal, and it became self-hosting. And so in that sense, it's radically different from Ruby, but the people that wrote Crystal were Rubyists, and they liked the ergonomics of Ruby. They just wanted the ergonomics of Ruby with, the intention was to have something that was a lot faster and also that was typed. And so those were the two driving goals, was to essentially create something that felt like Ruby, and in most cases looks like Ruby, but is fast and is typed. And actually, I'll throw in one quick caveat about the slide deck. I wrote the slide deck last year when Dan said, yeah, I've got a slot for you. And that was before Ruby 3 came out. And so there are a few things in here that I probably should have updated, but it slipped my mind to get back around to doing it. So there are a few things later on that I'll talk about that have some caveats, because Ruby 3 has changed some of the stuff that is important to Ruby, especially around concurrency. But anyway, so where was I at? Crystal. One of the things about Crystal is packaged as there's a single command, Crystal, that does your compilation for you, but it also does other things. You can use it to run your code, to format your code, to run your specs. It's like, it's like Go. If you're familiar with Go, and hey, you can use the Go command line to do a whole bunch of different stuff. Crystal's like that too, because Go is the other, I guess, major language that has inspired Crystal other than Ruby. And so as I mentioned, Crystal is statically typed and it's got type inference, which means that while everything in Crystal has a specific type, every variable has a specific type, in a lot of cases, you don't have to specify what that type is. Crystal will look at your code, and if it can figure out what type it is, cool. You don't have to tell it what type you've got going on. Along with that, it has type checking. And this is in Ruby 3.0, we have typing now and we have type checking, but it's an opt-in sort of system where you have to install extra stuff in order to do that. In Crystal, it's a mandatory part of the system. If you don't type something correctly, when you go to compile it, it's going to tell you about it. And usually the error messages are very explanatory. So in this case, for this little example, I declared a hash, but I didn't tell it what kind of hash it is, what's going to go into the hash. And so Crystal can't compile that because it doesn't know what the typing is on that hash. One of the other nice things that it does for you is it does null reference checking. And this is another thing that is something that was added in Ruby 3 with RBS. It'll do null reference checking for you. And this comes in, this is really useful when you're writing code that gets really big. Sometimes there are situations where you assume you know what's going on, you assume you know what data types are going in and what to expect, and everything will work as long as your assumptions are right. But when you have an incorrect assumption, and hey, a cat just decided to come visit. If you have an incorrect assumption and a nil, hello, I guess my login to New Relic just timed out. Sorry about that. If you have an incorrect assumption and a nil sneaks into there, it'll blow up at runtime because, hey, there's a nil where you didn't expect it to, and now, undefined method, there's no defined method of whatever on nil. So the compiler will find all of those cases for you ahead of time. So you never run into that case in a running Crystal program unless you opt into it. There's a way to tell the compiler, hey, you're wrong, I'm right. There's really no way for a nil to get in there, just let my code run. And it'll do that, but if it turns out you're wrong, then you'll get a runtime exception and it will blow up. The other thing about Crystal that is, it's less different about Crystal than Ruby now with Ruby 3.0 than it was previous to 3.0, but the concurrency in Crystal is a CSP style concurrency like Golang, which means that you have functions that are off running on their own, and they communicate with each other via message passing through channels. Ruby 3.0's Raptors are really a flavor of CSP, where you have units of execution that communicate with each other through channels. So with Ruby 3.0, this isn't quite as different, but with Crystal, it's very much a concurrency model that is based on Golang.
So sorry, Kirk, one of the other people in the chat said that the code's a little bit fuzzy with this. And I don't know whether that's because of it's actually a little fuzzy for me too. I don't know if I want to try sharing the screen and seeing that's a little bit better.
So let's see here. Yeah, we can try just sharing the screen and then I can just pop back to this view if I want to show some code or something.
Thanks.
Yeah, let me see. Where did I put you? There you are. All right, we'll see if this looks better. Just let me know.
Yeah, okay. That's much better.
All right, cool. All right, we'll just drop back to the other view if I want to share code or something like that. All right, so anyway, where was I at? CSP style concurrency. So getting down into the weeds here with the actual syntax, the syntax looks very much like Ruby. This code is valid in both Crystal and Ruby. You can't, it's valid code in either language. And for the most part, when you look at a Crystal program, it's going to look like a Ruby program. The main area where things are going to look different is in the type declarations. And so this is an example of a couple of those. And if you've looked at RBS for Ruby 3, you'll see that the syntax in some cases is kind of similar. And while I don't know this for a fact, I think that that's because when they were devising the RBS specification for Ruby, they went and looked at what Crystal was doing, because I found some threads where Koichi was in the Ruby forums asking lots of questions about Crystal and how the typing works and how the concurrency works. So I thought that was kind of an interesting sort of back propagation of some features. But other than the typing stuff, Crystal code looks a lot like Ruby code in most cases. Now, yeah, Ruby is dynamically typed. Crystal is statically typed. The type checking is pretty smart. So, everything in Crystal is an object, and an object is very loosely defined as it has a type and it has methods. And there are a lot of built-in types for all the standard things. I'm not going to really go over those in detail. It just basically it covers all the things you might want to worry about. And all of the data types are really pretty much Ruby-esque. There are a couple of exceptions as far as tuples and named tuples, which are a little bit different than what you have in Ruby. But for the most part, it's pretty Ruby-esque. The typing system, though, the type inference is pretty smart and pretty transparent. So like I showed in that one earlier example, if Crystal can figure out what your type is, you don't have to specify it. And if it can't figure it out, so in this case, there is an array being declared without any information about what array is going to store. Again, it'll give you an error message that makes it very clear what the mistake was and how to fix it. And so, yeah, this is just an example that kind of goes right along with that. It just shows that this is actually Ruby code. It's valid Ruby code, and it's also valid Crystal code. The type inference figures out what you're doing, and it works just fine. And so this is another example of valid Ruby code that in this case is not valid Crystal, because what's happening is that you've got a method that is adding X and Y, and oh, actually, wrong slide. This is just an example of what Ruby does when you have a typing error. If you're doing something where you're adding two things that can't be added together, for example, you get a runtime error with Ruby. Whereas with Crystal, if you do that, you'll get a compile time error where it'll say, hey, there's not a method that matches what you're trying to do. I can't build this code. So there is, a Ruby way to deal with that, which is that you basically cast one of your arguments into the type that you're expecting before you call the method, using a like in this case, 3.2s. And that will work in Crystal. Crystal has all of the type conversion methods that you're used to in Ruby, so that will work. But there is a more Crystal way to do it, and that is Crystal supports method overloading. So you can define two methods with the same name, but with different argument signatures. And so you can make it very clear in your method definitions how to handle the case when you have different arguments that are all going to go into the same method name. And that's really, really useful. A lot of times when I've written Ruby and I'm doing something where I might have a function that can be called in a couple of different ways. And ultimately, it's going to do the same thing, but there's some differences in how I can provide the data to it. You have to have a little bit of logic there in your method that says, okay, if we get this argument and this argument, then we're doing it this way. But if we get this other argument, we have to do some special stuff first in order to get to where we're at. We actually are at a common ground to run our code. And you can do that in Crystal, but that's not the way you should do it. You should just have overloaded methods that have different argument signatures and handle it from that point down. Now, one thing that you can also do with the typing, and this is actually identical to the way RBS does it, is if you have something where you have an array where you want to be able to store both strings and symbols, you can define a union, a type union, which is a union of types, and you can say that, okay, we're going to allow multiple things. And this syntax is actually identical to the syntax in RBS for type unions. Now, one thing that if you're a Rubyist going to Crystal will trip you up every time for a while is quotation marks. There is a what's the word? A best practice in Ruby of using single quotes in places where you're not interpolating strings. And you know, there are opinions about whether we should always use double quotes even in Ruby versus having that confusion between single quotes and double quotes, or only using single quotes for non-interpolated strings or whatever. But in Crystal, single quotes are only for expressing characters, single characters, and double quotes are for strings. And so when you try to use single quotes on a string in Crystal, it's going to blow up. And yeah, I guarantee as a Rubyist coming to Crystal, I still mistype these things sometimes, banging away at the keys, and I quote a string, and then yeah, it blows up because I used the wrong set of quotes. My brain was on the wrong language. So yeah, the type inference and type handling is complex, but most of the time it just works. And when there is an error, Crystal lets you know where the error is at. And usually the error message is very explicit and very specific and tells you exactly what you did wrong. Nonetheless, as a Rubyist coming to Crystal, dealing with types is probably, it's probably the single biggest thing that you have to wrap your brain around in order to start writing the code. It just, you know, we're so used to not even worrying about it in Ruby. And to have to sit there and think about your typing and think about the consequences of those decisions, it takes a little bit of a brain adjustment to get around to dealing with that. So the other thing about Crystal that is different than Ruby, and again, it's more different, it was more different before Ruby 3.0 than it is now, is concurrency. As of version 0.36.1 of Crystal, which should be the last version before the 1.0 release, the default mode of operation for Crystal is still to be single-threaded, but you can opt in to being multi-threaded. The main concurrency primitive is a fiber, and Crystal fibers are really like Ruby fibers with some added amenities stacked on top of them. And they use channels for communication, and channels are really just pipes where you feed a data value in at one end and it can be popped off at the other end. So you can think of them as like a queue. But Crystal has a built-in event loop for efficient handling of I/O. Now, as of Ruby 3.0, they have integrated the async library into Ruby to provide that built-in event loop as well. So this isn't so much different as it used to be. And that built-in event loop with async in Ruby 3.0 provides some of these same features that come for free in Crystal. So it's a little bit closer now with 3 than it was with the previous Rubies. So yeah, crystal fibers are more or less conceptually synonymous to Golang coroutines. The only difference is that Golang coroutines are preemptively scheduled, so they're like threads. The runtime will make sure that every Go routine gets a slice of time to run, whereas a crystal fiber, when it's running, well, there's actually a caveat to this. A crystal fiber in single-threaded mode, when it's running, and nothing else is going to run. If you compile everything in multi-threaded mode, then the crystals are also preemptively scheduled exactly like Golang. So there is that difference. Ruby fibers, especially pre 3.0, required you to do absolutely everything for yourself. So you had to schedule the fiber, you had to yield the fiber, you had to do all of the low-level management of concurrency yourself on those fibers. And this slide basically says the same stuff that I just said with a little bit more details. I'm going to kind of slide over it because so yeah, I threw this slide in just a little while ago just to make sure to bring up this point. Ruby 3.0 really is a game changer for Ruby in a lot of ways. Because of the concurrency stuff that was built in. I think that the typing stuff that came in with RBS and stuff is going to be really useful for large code bases in particular. But the concurrency changes that came in with Ruby 3.0 it can't be understated how big these changes are, because they add a lot of capabilities that just didn't exist before. A lot of things that I guess I wouldn't say they didn't exist, but they were harder to do. They weren't first-class citizens in the language. And so Raptors are a really nice concurrency model. Like I mentioned, it's a CSP style concurrency, which makes it a lot easier to do things without shooting yourself in the foot. It's still possible, but it's easier to do things without shooting yourself in the foot. And the built-in event loop with async, async is really a fabulous framework. If you've never worked with it before, it's a fabulous framework for doing event-based IO with Ruby. And having that integrated in makes a lot of things a lot easier to work with in Ruby than it was before. Oops. All right. So yeah, this is just an example of one of the differences with how you wait for a thread in Crystal versus Ruby, because one of in Ruby, there's a thread.join, so you can just spawn a thread and you can wait on the thread, and when it's done, execution will continue. In Crystal, when you spawn a thread, it's off running on its own, and you aren't going to get any notification when it finishes. And so you have to do a little bit more work. And usually the way you do that is you set up a channel that is just it's a flag, basically. It's a notification channel. And you push a value down it when the thread finishes. And then you can just have your code elsewhere that waits. Just sit there and listen on the channel until it gets a value pushed down it to let you know that it's done. Now, what I have here is I have a breakdown of this is a Golang program that calculates Fibonacci numbers, and it also has a little spinner that sits there and just gives you something to look at while it's calculating. And in Golang, it's a pretty simple, straightforward program, because the Go routines, because you can just fire one off and it goes and it does its thing. There isn't a lot of hand-holding that you have to do with that concurrency to make it all work. And if you come and you look at the Crystal version of it, and I know that this is kind of small, so I could actually switch to a shell or VS Code and show it to you a little bit more clearly if it's hard to read. But the Crystal version of it is structurally pretty much the same as the Golang one. There's a little bit different verbiage, and I use more lines here, but structurally the Crystal one is pretty much the same as the Golang version. Whereas if you do it in Ruby, there's really two ways to do it in Ruby. If you do it in Ruby with fibers, it's a big hassle. You have to have a lot more lines. You have to really hold, you have to do a lot of stuff manually yourself as far as managing when fibers run, when fibers yield to each other. It's a really big hassle. And with Ruby, you can do it with threads, and then it becomes much, much simpler. And with threads, it's going to look pretty much like the Golang one or the Crystal one. It gets very simple again if you use threads in Ruby versus fibers in Ruby. But there's a big performance difference. And that should say with Ruby 3.0, because I went and retimed all these, but I guess I didn't change the header. So, that's with Ruby 3.0, without the JIT, 76 seconds on my CPU to calculate a Fibonacci of 45. With the JIT, it's way faster, 24 seconds. The Go version calculates it in a little over 5 seconds, and the Crystal version in less than 4. So, the Crystal version is substantially faster. And that speed difference too, by the way, between the Crystal version and the Go version, you'll see that pretty much with anything that you write in Crystal. If you write an equivalent implementation between Go and Crystal, the Crystal one's going to be faster. And yeah, I just wanted to point out that huge, huge performance increase with the JIT. In Ruby 2.7, there's still a performance increase, but it's about 2x versus 3x, which is where it's at with Ruby 3. So that's there's still a lot of workloads where the JIT doesn't help, but on things where you're doing a lot of really repetitive stuff, that JIT can really make a huge impact in the performance of your Ruby program. Yeah, and so I mentioned that earlier, that Crystal, it runs an event loop for you. It's part of the language, which Ruby 3 does that now too. So that's not as much of a differentiator as it used to be. But massively, it's still very, very fast when it comes to doing a lot of massive I/O. When you're doing a lot of, well, this example goes and searches through files and just adds up how long they are. And I wrote an equivalent version of it in Ruby using threads. And so the code is pretty similar. If you go and you look at the two, the actual appearance of the code is pretty similar between Ruby and Crystal, using Crystal fibers versus Ruby threads. But the performance of it is substantially different. I ran it on the actual Ruby repository. So I just counted up all the lines in the entire Ruby repository. And this was running under a laptop using WSL1 that I ran these timings on it. And so you can see that, Ruby did it pretty fast. It counted all of the lines in all 10,000 files in under 2 seconds. On WSL1, which does not have the fastest file I/O, it's pretty slow. But Crystal still did it several times faster. Now, this is just something that I think was kind of interesting. This next little section is something that Koichi Sasada brought up when he was asking some questions about how the concurrency model works. And it brings to light the fact that even if you're using something like a channel, if you're using some sort of message passing with your concurrency, and this goes for Ruby too. I'm sure that we could take this example that I'm going to show you and create a Ruby version of it using Raptors that would have the same problem. But even when you're doing message passing with channels, you can still get state that is weird. And so we have this simple little program, and it does a simulation of IO, where we're going to go search the internet for people and get their age. And it spawns a few different fibers in order to do this simulation. And what happens is when you actually run this code, you can see from this code here, when you're searching for Carol should be 30. But what you actually get is that Carol is 10. And the reason for it is because of, well, you end up basically with a race condition. And if you aren't synchronizing your accesses to shared data, you end up with a race condition and you get the wrong age. And so you have to make sure that whether you're using, that you don't share data, that you pass data around the right way, or that you synchronize your accesses of that data in order to ensure that you don't end up with surprises. And so in this example, by using a mutex and synchronizing my access to the search, you can get the right answer. You could also get the right answer if you were, instead of sharing data, you did a share nothing model and you just made sure that you were passing messages and not doing anything but passing messages. And if you did that, you'd be safe. But you can still shoot yourself in the foot if you aren't careful. So one of the big areas of differences between Crystal and Ruby is that because Crystal is compiled, it doesn't have support for a runtime eval. You can't, in your program, go take some code and eval it and have something new running, because Crystal's compiled, and it won't go and on demand compile new code for you in the middle of your program. So that makes a big difference in how certain metaprogramming is done, because there's a lot of metaprogramming that really fundamentally depends upon dealing with code at runtime. And Crystal also doesn't support the send method, which means, this is also used a lot in metaprogramming, where you can have one method that goes and looks at what was actually invoked and says, okay, we're going to analyze this, and then we're going to dispatch it to some other method based upon what it was called and what arguments were passed. It's a way to do cool things with your DSLs. And while it's possible to implement a send in Crystal, it's kind of mystical, magical voodoo, and really you shouldn't do it. And so you have to do metaprogramming a different way with Crystal than with Ruby. And so what Crystal does support is it supports something that are called macros. And a macro is really a language that is kind of a subset of Crystal, that is designed for taking the AST that is generated at compile time and manipulating it so that you can essentially write code to write code. A macro generates new code for you. And so using that, you can implement pretty much any sort of metaprogramming that you can implement with Ruby. It just happens at compile time. The macros run and generate code for you that then gets compiled. And I have an entire presentation could be done on it, but I have just a really simple example of it here. There's a macro here, define method, that just takes a name and some content and defines a method with that. And so then we define a method 7 that returns the number 7. It's about the most trivial example possible, but this is how metaprogramming is done in Crystal. And so the metaprogramming aspect of Crystal is probably not, well, it's definitely not as friendly as with Ruby. But on the flip side, it is really powerful. And again, you end up with really fast compiled code when you're done. Now, one other place where Crystal really shines is in C bindings. basically you can take a C library and you can just use it. There isn't any other special stuff that you have to do. You have a first class syntax that says link to this C library, and then you can just write a piece of Crystal code that says, here's my C library, here's the functions that I can call on that C library, and they're available. You can call them just like Crystal functions. You can pass them data the same way that you would pass Crystal functions data, and it just works. So it's really amazingly trivial to interface a Crystal program with any given C library. Now, a lot of C libraries are pretty obtuse. You know, they aren't designed with the user friendliness in mind that a Ruby programmer is used to. So in those cases, there's more work that you can do when you're writing your bindings so that you can wrap it up into nice ergonomic stuff. But the actual mechanics of binding to the C library is almost nothing. You just put it in there and use it, just like you're requiring any other Ruby library, more or less. Now, Crystal does have a whole bunch of other tooling that is bundled with it, like I mentioned. There's a testing library that is actually pretty much RSpec. It has scaffolding built in, so you can do, like with Bundler, you can do Bundler gem, and then it'll build a skeleton of a new repository for you. Crystal has that built in so that you can do a Crystal init and have it build a skeleton of a new library for you. It's got its own, they aren't called gems, they're called shards, but its own package manager. There's a whole bunch of things like that that are bundled into it as just built-in tools. And so like tests, like I said, Crystal's spec system is basically RSpec. There's some subtle little differences, but more or less it's RSpec. And yeah, this is an example of just building a new repository. All that tooling is built in, and shards are the equivalent of Ruby gems. The main difference is that shards utilize YAML as a definition language. And so a shard is not itself executable code like a gem is, or like a gem file is, a gem spec. It's a shard is YAML that defines all of the data elements that go into defining a package. It'll auto-generate docs for you. And this one I use all the time. It will automatically clean up your formatting to the Crystal standard, and it works really well even on weird code where you have things that you maybe think that they might not have thought about. It does a really good job at cleaning up your code. So I'll kind of cap this off with a really simple rewrite that I did. One of the first things that I did when I started looking at Crystal in earnest was to take some Ruby code that I had and rewrite it in Crystal. And in this case, it's a simulation. It's a dice rolling program for a role-playing game that simulates rolling some dice and generating some probabilities based off of that rolling. And so it's fairly simple in how it works. And the actual code is very straightforward. It's not sexy Ruby by any means. It's very straightforward Ruby. And so when I went to rewrite it in Crystal, first thing I did is I just tried to run the Ruby code in Crystal, and it blew up. And it blew up with a typing error because I hadn't defined the type for the array. And so I defined the type for the array. It's an array of 32-bit integers. And then I ran into this. Crystal has the same sort of thing as Ruby does. Ruby has attribute reader, attribute writer, attribute accessor. In Crystal, they're simply renamed. A reader is a getter, a writer is a setter, and an accessor is a property. And so, changing this to just getter dice, getter plus, and then putting the typing, and that error was taken care of. And that's all I had to do on that little code base was those 3 lines. I changed it, and then this was compilable Crystal code. And, you know, it's just sort of, you know, bringing home that performance difference. This particular code does 1 million dice rolls and uses that to give you probabilities of what will actually happen. And it's much faster. The Crystal versions are much faster. These were all timed on a laptop on WSL1. And this was under Ruby 2.7. So under Ruby 2.8, the JIT, or not 2.8, under Ruby 3, the JIT would probably be a little bit faster than this. Instead of 13.44 seconds, you know, a little bit faster. But with this particular dice rolling example, the JIT did not significantly increase performance over the non-JITted performance. And so, you know, to wrap this up, the one, I guess, big question that I often get about Crystal is, it's still not 1.0. You know, why would I use this? It's still not 1.0. And it's been a remarkably stable language for the last probably year. There haven't been really many significant breaking changes that have come into the releases. They've all been relatively minor changes. There've been a few breaking changes, but most of those were to fix poor decisions from the past. And the 0.36.1 version that was just released last week is probably the last version that will be released before 1.0. Pretty much all that's left between now and 1.0 is some cleanup of a few things, and there's some deprecations that they want to get rid of and a few things like that. But more or less, it's a solid almost 1.0 product. I've been banging on it now for 9 months, really hard, and have run into absolutely zero problems with language stability or you know, anything that I can attribute to language maturity issues. It's been rock solid stable and just does what I want it to do when I want it to do it. So, questions?
I have a question actually. I think you did a great job of talking about like the nuts and bolts of why, or like how to make a decision, you know, or how to translate something from Ruby to Crystal. But
yeah,
I guess the question for me is why would you pick Crystal?
Why would I pick Crystal? I guess it depends upon what your use case is. If you're writing anything where performance might be a consideration, and I know for like a lot of web stuff, Ruby's fast enough, and especially Ruby 3.0, it's fast enough. But if you are writing something where performance is a consideration, Crystal's performance is blazingly fast. If you're writing anything where you might want to distribute a binary, you know, it's really hard to write Ruby code that is easy to distribute. If you want to write something that you can distribute to other people, it's hard to do in Ruby. And people have tried to come up with various solutions that will create an executable by basically bundling all the libraries that are needed and stuff like that. None of them work very well. It's really hard to do. Whereas with Crystal, you can compile a binary, and you can statically compile it as well. So you don't need, you don't have to depend upon, the system having the right libraries to link to. You can statically compile your binaries and distribute them. And the binaries are pretty small. Yeah, I'm trying to think of a good example. I have a piece of software that is it's basically a data collector. It's a daemon process that remote agents can connect to and feed data to it, and it goes and it'll store it into Postgres or wherever. And the compiled binary for this thing is 7 or 8 megabytes, I think. It's not very big, and it's a substantial amount of code. So the binaries are pretty small, and it's, you know, it's easily distributable. I think those are the main reasons. Type safety, you know, again, Ruby's got type safety now, but it's still, I don't know, I've played with RBS. RBS is a lot harder to use seamlessly and in a pleasing, productive way than the typing is in Crystal. It takes a lot of extra work to use RBS versus the typing in Crystal. And so, you know, there's a lot of controversy about typing. You know, a lot of people hate the idea of typing in Ruby, but typing can save your butt sometimes because it can find errors that you just didn't know were there.
Thanks.
So anybody else have anything?
Yeah, I have a question. So besides the concurrency stuff, which now sounds pretty parallel feature-wise in Ruby, what actually makes Crystal so much faster than Ruby and Go?
It's really that, I mean, there's a lot of reasons why Ruby is the speed that it is. A lot of things go into that. But what makes Crystal fast is really that it's built on top of LLVM. So fundamentally what happens is your program gets compiled down to a language that LLVM then turns into executable code, and LLVM does a really good job at optimizing that code. Rust was another language that, you know, one of the key things that people like to talk about with Rust is how blazingly fast it is, and Rust is built on top of LLVM. So in the same way, Rust compiles down to a representation, an LLVM representation that is then compiled to a binary, and that's what Crystal does too. Generally, Crystal's a little slower than Rust, but there are some reasons for that too. Crystal has built-in garbage collection and stuff like that, which affects performance.
Got it. Awesome. Thank you. Great presentation. I am curious also if you have any idea of, even though it's pre-release, like the overall adoption of Crystal just in the industry.
You know, it's interesting. There are a fair number of companies that are using it in some capacity. There aren't a lot of big companies that are using it. It seems like there are a number of security companies that have started using Crystal, and I'm not really sure the reason why. I just know that I've seen, you know, from code that's been published or comments that have been made in Twitter and elsewhere, that it seems to be a pretty popular language amongst security companies who are writing tooling. But I've also seen in the last 9 months, there's sort of a growing, accelerating curve of interest in Crystal, because it's, I first found out about Crystal in 2015. There was a presentation on it at Ruby Kaigi, and I went and I looked at it and I thought, oh, that's interesting, but I can't do anything with it. And so I kind of forgot about it. And I forgot about it until I saw something about it last year. And I was sitting here at home, COVID, jobless, and needing something to do. And so I just started digging into it. And I found that in the intervening time, it had become a language where I could really do anything that I wanted with it. And I think that a lot of people are starting to discover that now as the curve starts to move up. And so I see a lot more adoption coming in this year than in previous years.
Got it. Awesome. Yeah, I use Go every once in a while for things I need to be performant, so I'm definitely going to check out Crystal. Thanks again.
Yeah, because I think Go is an ugly language. It
Yeah.
hurts my soul every time I try and write code in Go. And so the fact that I can go write something that feels like feels like Ruby and comes out of my fingers like Ruby, but is faster than Go, it's really nice.
Yeah, definitely. Awesome. Thanks again.
Yep.
Kirk, I had another
Yeah.
question. What's the library situation like? You know, again, this gets back to the usability features. Is there good solid database libraries? Are there good
Oh yeah.
web
Yeah, I
frameworks?
mean, The standard library itself is really complete. Basically, it looks like what they did is they took everything that made sense from Ruby, and in some cases they fixed things that looked like poor design decisions in Ruby. So there are some things that are a little bit different. The time library is a little bit different in some of its methods than what you'll expect coming from Ruby, for instance. But the standard library is really complete, and the standard library includes a database interface library that is standard in it. And so there are then the third party part is the actual drivers to the various databases. So the interface is standard, and then you write a driver that complies with the interface. And so there's drivers for all of the typical libraries, or all the particular typical databases. And there's libraries for really pretty much anything. Some of them, because it's a young language, it's more like Ruby 10 years ago, where you might go look for something and, oh, there's a library for that. Oh, but it hasn't been maintained in 2 years. You know, so there is a little bit of that, but again, it's getting more and more solid all the time. And I really haven't run into many situations where I wanted to do something and I couldn't find a library for it.
Great. Any other questions for Kirk? Well, Kirk, if you have a chance, you should read through the chat. I've seen a lot of people saying thank you very much for the presentation.
I was sort of glancing over at it a little bit, but trying not to look that way too much. Yeah.
Great. All right. Well, I guess that's everything. Thank you again, Kirk and Taylor. Really appreciate you guys taking the time, you all taking the time to talk. So I'm going to stop recording and
yeah, I just wanted to say, if you have any questions about anything, I'm W.Y. Haines everywhere on the internet. So you can email me at WYHaines at GitHub. You can find me on Twitter. You can find me everywhere at W.Y. Haines. And so, you know, if you have a question, contact me. I'm happy to talk about it.
Awesome. Thanks. All right. So thanks again, everybody. Actually, do you want to paste that, Kirk, into the chat? I think I see some people asking questions. And again, thanks everyone for showing up for Ruby, Bold Ruby Meetup.